Hey folks, welcome to my talk and welcome to React Mumbai. So today my talk is about scaling your JavaScript application using Docker and Kubernetes. Before diving into the talk, let's imagine something. Like, why do we really need this talk? Okay. Now, let's just think that you have built the coolest JavaScript application out there. Maybe it's like a React application for tracking the number of times someone is hitting add to cart on an online store, or maybe it's a Node.js application for the world's most useless yet addictive trivia game. Now, life is great. Your app is live and people are loving it. Then assume disaster strikes. Suddenly, your application is so popular that it crashes because your server cannot handle the traffic. And users are getting angry, your application's memes are trending on Twitter, and you're just sitting there and wondering, wait, isn't JavaScript supposed to handle all this and fix everything? But that's when you realize that you really need a better plan and you need a way to make sure that your app does not crash even if the whole world decides to log in at once. And that is exactly where today's topic comes into the picture. That is scaling your application with Docker and Kubernetes. Now, these simple tools, not exactly simple, but yeah, these tools helps you keep your cool by ensuring that your app stays online no matter what. So I think, yeah, that is why we need today's talk, and let's jump into the world of scaling a JavaScript application. And do not worry, I promise I'll keep it very simple and fun. So let's move forward. Yeah, before diving in, I think I can give a little bit introduction about myself. So I'm Faeka Ansari and I'm currently a software engineer at Aquiri where I work for Cargo. Cargo is like a simple tool again, which helps you to automate and manage the process of moving your software changes smoothly from different environments, like from testing environment, to development environment, to production environment, and stuff like that. That's like a brief intro of what I'm doing at my job. But apart from that, I have had the privilege of contributing to several endeavors. Like, I'm a Gold Microsoft Learn Student Ambassador. I'm also a GitHub Campus expert. I've contributed to some really cool cloud native projects like Kubernetes. If you want to learn more or talk to me, you can hit me on LinkedIn. Yeah, so I think before moving on, I would really love to talk a little bit about Microsoft Learn and the journey it took me on. So I'm a Microsoft Learn Student Ambassador, and it has provided me tremendous opportunities, like one of which is speaking with you guys here today at React Mumbai. Since we are at React Mumbai, I would want to talk about how Microsoft Learn helps you in your React journey. So Microsoft, of course, has always been promoting React in terms of supporting it in its own IDE. Like, Visual Studio Code has a ton of extensions for React. And if you really are looking forward to learn more about React, I think there is also this really cool training where you can learn more about React and create your first web application from scratch with React. And if you are interested in the whole Microsoft Learn Student Ambassador program, I'm here to help you with that as well. So this is the link on the screen where you can go and apply for the program. There are quarterly applications that opens up, but you can definitely apply, and yeah, all the best for it. Now, coming to the agenda for our talk of the day, that is scaling our JavaScript applications with Docker and Kubernetes. I would want to quickly go through it. So I would start with a very brief understanding the basics of Kubernetes and Docker and what they mean for scaling your applications. We'll go through the overview of how your Node.js applications or all these things are built to scale. And then we'll talk about what if you already have your application out there and you want to transition it to Docker or Kubernetes. So we'll talk about it, some key changes that you need to make in your old legacy applications to adapt to Docker and Kubernetes, and how you manage your environment variables and things around it. I'll definitely cover some of the benefits of using it, and I'll get you motivated at least by the end of the talk so that you go and explore it by yourself and get ready for scaling your web application. First topic of the day is why do we need Docker and why do we need Kubernetes? So think of it this way. You see that dolphin sign on the screen, that is basically the symbol or icon or logo of Docker. And Docker has actually changed how developers work. Now, what Docker actually does for you is it allows you to create isolated environments for your applications. Now, let's say you would have heard this age-old problem of, hey, it works on my computer, but it is not working in production. You would have heard that, right? So that is where Docker comes in handy. It manages all of the dependencies, all of the configurations that your computer has, and packages it into a box, which we call as container. And that is how it makes your application not just run on your PC, but run across production, across several environments. So you can think of Docker as like a small mini operating system, where inside each box or inside each container, you have every single thing that your application would ever need. Like it will have all the binaries that your application need, all the dependencies your application would need. It will have its own isolated CPU. It will have its own memory. Yeah, exactly. Something like a mini operating system. So as you can see in the picture right here, there is like a moving truck which is sort of representing Docker, and it is like carrying these isolated, neatly organized application containers. And while doing this, it is also ensuring that they all travel smoothly together. That was Docker. But why do we need Kubernetes, right? Now, I told you like Docker will, do all the great stuff of packaging all the dependencies and everything into a box. But what if there are multiple servers in your application and you have multiple containers, multiple boxes packaged together? But how would you manage all of these multiple containers? Or if container is a very technical term, it's the first time hearing it. Basically, containers is nothing else but managing units of softwares that will package an entire application along with its dependencies, binaries, libraries, configuration files, everything. So you're just packaging it. So if there are many containers, how do you manage all of that, right? And that will actually become a big headache when your application is becoming larger and larger, and you're adding a lot of services and adding a lot of features and stuff. So that is where Kubernetes comes in. Kubernetes, which is something we often call as K8s, is basically this box managing platform. Now, what do I mean by box managing? I did not want it to go into the very technical term for it, which is container orchestration platform. Now, what do we mean by container orchestration? It's a huge word because it was for me, I remember. So what that means is basically container is the software package box and stuff. Orchestration is managing it, and Kubernetes gives you that simple platform for managing all of these containers. So it on ground helps you to automate the whole deployment, the whole scaling, and the whole management of these containerized application. So that is Kubernetes for you guys. Now, I hope I was able to explain why we need Docker, why we need Kubernetes, and what they do and stuff. But let's say you have already built the coolest web application out there and you want to move it to Docker. How would you prepare yourself for doing so? So let's talk a little bit about it. Of course, it's a very overwhelming process at first, but it is also a step-by-step process. So let's break it down into some simple practical examples. Before going into this, I think I would also want to cover, why do we need to move our legacy applications to Docker? I did cover a bit of it, but let's think of it again. So think of Docker as a shipping container for your application. Now, just like containers keeps your goods safe and easy to transport, Docker will ensure that your application and all of its dependencies will work consistently across different environments. Your computer, your friend's computer, your colleague's computer, and even your production server or your customer's computer. Okay, that is what Docker is doing. As simple as that. So I hope I was able to explain why we need to move it, and that is the whole point of us learning this. So now let's see how you actually move your legacy application to Docker. Legacy application is not a big thing. It's just like your outdated software packages which is just working on your PC right now and you want to scale it. So to do it, I think the first best practice and first thing that you need to do is please replace the hard-coded configurations in your code. So wherever in your own personal project you have been using hard-coded values, you need to change it, because it often happens that all of these old softwares and legacy apps have values like database URLs or API keys and all of these server ports and all of these directly embedded into the code. For example, you see this program here, you see that the URL is directly embedded in the code, which is a hard-coded configuration. Now what happens because of this is it creates a huge problem. Let's say if the database URL changes, you'll have to touch the application code. So say the database URL changes for the production, you will have to obviously update production every single time and redeploy your application every single time. There will be a major security risk, and you might also end up exposing some of your sensitive data like your API keys in the code base. So that is why it is very important to replace your hard-coded configuration if you want to work with Docker. So let's check how we do that. So the solution is using environment variables. Now how do we use environment variables? Is simple. Environment variables are some values that are stored outside of your code, and when it is stored outside of your code, it makes them very easy to change, because now you can just maintain a single file like a JSON file or anything, and you just pick values from there. So this stuff is outside of your code, so you won't touch your code every single time you want to make a change. Yeah, now let's talk about enhancing your security with containers. So if you see in traditional hostings, all of our applications on the same server share the same environment. So if one application is hacked, the attacker can literally hack all the other applications as well. Right? So with Docker, what you do is each application will run in its own isolated environment. You can imagine this like you're running, say, 3 legacy applications, as you see, app 1, app 2, and app 3, and without Docker they might all share the same operating system, right? So if app 1 has a security hole, and a hacker might gain access to app 2 and app 3 as well, just because of this. But with Docker, these applications will live in separate containers, like I said, mini operating systems for each of them. And if app 1 is compromised, the other 2 apps might remain safe. Cool? Obviously, packing your application into a Docker container. So what do we mean by that is simple. You create a Docker file. Now, what is a Docker file? It's just like a recipe that will tell Docker how to package your application. So it's very simple. It's as simple as that. You see the code right there. This file tells Docker to use a Node.js environment, and then it basically copies your application's file from your project, and then it builds and runs the Docker image. That is it. Now the application will be running inside a container and will be accessible on your localhost 3000. As you see, it is mentioned here in the command that you run for building the Docker image, that is Docker build, and then Docker run. Yeah, so we've spoke a lot about Docker. Now let's see, why do we need Kubernetes and how exactly that works. So now when you start using Docker to run applications in a container, it works great for small setups. But as you know, you are about to grow your application, and managing so many containers manually will become very difficult. And that is where Kubernetes will help you keep all of these challenges by automating your container management. So there are several challenges without Kubernetes, one of which is manual updates. So let's say you have a container which is running your application and one day it crashes. Okay, so what will you do? Let's say it has a bug or an issue with the server, and without Kubernetes you will need to log in and you will need to restart your container whole entirely, like manually. And if you have like many containers running at the same time, you might literally spend all day or all month fixing all of these crashes. So manual update with just Docker is sort of difficult. And second problem, which of course is the whole topic of the today's session, is scaling your application. So suppose your application becomes very popular and you really need to handle more users. Now you need to decide to run 3 containers instead of 1 container to balance the load. Now without Kubernetes, you must manually start multiple containers using the code like docker run on this port, docker run on that port, and stuff like that. But you also need to figure out how do you direct users to these containers. And honestly, that's a lot of work for something that Kubernetes can easily automate for you. And of course, downtime during updates. So of course you will update your application, you would want to bring some version updates and stuff like that, and during that time to deploy the update, in general you'll have to stop the current container and then update it and then host it back. This way there will be a downtime for users. So if there are millions of users using your application, you would not want that. It'll be a huge loss. So that is why you start a new container with the updated app, but during this time, when users cannot access, that is where Kubernetes comes into picture, and it'll help you with updating without a downtime, like with zero downtime. Let's see how we do that. So Kubernetes in itself will take care of container management for you, and it will automate all of these tasks like restarting your crashed containers or scaling your application or even updating it without any downtime. So how does it do so? With automatic restarts. This is a very beautiful feature which self-heals itself, so your apps will heal it by itself. Kubernetes will monitor your application containers all the time and it will restart it automatically if anything goes wrong. It will also log the information for you to debug in the future and stuff like that. So yeah, I mean, this is such a cool feature. Like, just imagine if your application crashes at say 2 a.m. at the night and you'll have to wake up and run a command to restart it. But with Kubernetes, it will just detect the crash and it will just restart the container automatically, so you can sleep peacefully. Yeah, that is about Kubernetes. Now let's talk about how Kubernetes actually solves this with a real life analogy. Imagine you are running a food delivery service like Zomato or Swiggy, and you have if one person in the delivery team falls sick, you must have to call someone and replace them manually, right? But with Kubernetes, the system will notice the problem and they will automatically assign a new delivery person for you. Okay, similarly, if there is a scaling issue, so without Kubernetes, if there are 100 people ordering food, you will need to call extra delivery people yourself. But if there is Kubernetes, the system will detect this demand and will hire temporary delivery people automatically for you. So that is how Kubernetes is working. So yeah, and the zero downtime upgrade is also very much relatable to a food delivery app. So without Kubernetes, if you wanted to add a new dish to the menu, you will have to close the restaurant. Okay, I'm building a new dish. But no, with Kubernetes, the whole restaurant will stay open while the new dishes are gradually added, so the customers are never affected. That is how Kubernetes solves so many problems. Kubernetes is like this very smart manager for your Docker containers or your Docker boxes or your software packages, and it watches over your containers to make sure that they are running smoothly, and it handles all the traffic whenever it increases by adding more containers, by removing containers, and it keeps your application available even during updates. So, by using Kubernetes, you can focus on your application's code, and Kubernetes will take care of all of the rest of the things that goes with managing. Yeah, so now since we are in React meetup, let's talk about how we do so when you have a JavaScript based application with React Native in it. So when only a few people use it, right, a single server can handle all the requests in JavaScript. But let's say if your application goes viral, as I said, one server might not be enough, and you will need more servers running your application to handle the increased load. This is where scaling is very important, and that is where Kubernetes acts like your reliable team manager, where it will hire extra hands during busy times. It will replace the workers who are not working properly, like self-healing, and it will keep the shop or your application running smoothly whenever there is an update and stuff like that. Now let's see how we put Kubernetes into action, because we saw how we transition our legacy applications to Docker. Now let's see how we bring Kubernetes into action with your application. So Kubernetes works on a very simple stuff, that is YAML files, and you really just need to learn YAML and about some configurations of how Kubernetes works, and you're very good to start doing stuff with Kubernetes. So for Kubernetes deployment runs your application and containers, and they ensures that they stay healthy. So you can think of it that these are like the managers who are running your coffee shop, like I said, and this is the manager file, or what we call as the YAML file, which we use so that we can decide how the whole deployment works. So if you're deploying your JavaScript application, you will basically create a deployment file and mention all the things that you want Kubernetes to do. Like this deployment file has a spec section and replicas that you want two versions of your software to be running all the time. You want a selector to match with certain stuff so that it matches to a service and all of those things. The template field where you define the configurations of your container. So if you see, this is a JavaScript container which is running the image Node.js 18 Alpine, and it is running on the port 3000 and all of those things. So this is a very simple YAML file where you can mention the things that you want your Kubernetes application to perform. Yeah, and the self-healing property that I told about, this is how we added in Kubernetes. It is as simple as that. All these features are just through a YAML file in Kubernetes. So you see that the self-healing property is simply mentioned here by this template. This template will keep repeating, and whenever something crashes, Kubernetes logs it down, and Kubernetes will keep checking these logs. If there is a crash loop back off, or if there is any sort of error, it will restart the whole deployment file and make sure that there are two replicas, as you see here, running, which has this similar configuration. So this template defines what should be running, and it will make sure that it is running in the best state possible. And if any pod crashes, Kubernetes will spin up a new one. It exposes your application to external users or other services within the cluster while keeping all your pods safe inside the cluster. Okay, so now that we have explored the individual components, let's now quickly explore everything and see how these pieces interacts in a real world setup. So as you see here, there is a load balancer, which is sort of like a traffic manager for your application. So when users access your application, your JavaScript application, their request will be routed to a load balancer, and that load balancer will of course route this to the service, and this service in turn will forward the traffic to one of the multiple pods which is running your React application. Yeah, I think now it's time for a closing note. So as React developers, you are already building amazing front-end experiences, and scaling your applications with Docker and Kubernetes in your is something which is your natural next step. So that is why I would want you all to go explore Kubernetes and Docker. And next time you are building a project, please build it to scale it. Yeah, thank you so much everyone. As React developers, you are already building some amazing front ends out there, and scaling your application is something which should be a part of your journey. I really hope this talk empowered you all to bring some bring the same level of efficiency and flexibility and scalability to your applications and your code. So I encourage you all to go check it out. And if you have any questions or you want to share your experiences, feel free to reach out to me. And if you want to get started with your cloud native journey, I'm also a CNCF ambassador. I would love to help you guys. And yeah, thank you so much for your time and happy coding.